Okay, I'm going to talk about electromagnetism for a few minutes. This unit really we focused on like the connection between electricity and magnetism. We said that electrons, when they're moving, they produce a magnetic field. Um, so a current makes a magnetic field. Um, we also talked about electromagnets. How do we make an electromagnet? What makes it stronger? There's a couple of different ways that we looked at that. So I've got a few questions on those. So here we've got some students. They've got a bar magnet and a coil of wire, and they're using a galvanometer, which measures current. Okay. And so they're moving the magnet in and out of the coil. And they ask what's most likely to be observed by the students. So the current's larger when the magnets move more quickly. The current's smaller when the magnets move more quickly. The current's the same. There will be no current in the coil. So one of the things we learned is that if you have a changing magnetic field, you can induce a current. That's called electromagnetic induction. So inducing a current. Okay, so when we move this magnet in and out of this coil of wire, we can induce a current in the coil of wire. We can get those electrons moving. And the more quickly we move our magnet, the more current we induce. So this one is A. The induced current is larger when the magnet is moved quickly. The magnet has to be moved. So if it's not moved, you're not going to see any current. Okay, so the point is that it's got to be a changing magnetic field. So as long as you're moving the magnet, you should get some induced current. But it's going to be better, a stronger value if you move the magnet more quickly, because then your magnetic field is changing more. What are some ways to make an electromagnet stronger? So we've talked about this like a billion of times now, and we did a lab similar to this setup here where we had a battery and a coil of wire and a nail. And so things we can do to make an electromagnet stronger: add more coils so that I've got more coils for the electrons to travel through. Increase the voltage. We already know that current and voltage have a direct relationship. Let's see, use a more core. Okay, use a bigger nail, an iron core. AC to DC doesn't really matter. That's, remember, alternating current to direct current. Decreasing the current, that's not going to make it stronger. Reversing the poles in the magnet is not really going to matter either. So our key are kind of those three C's that we talked about: current, coils, and core. If you increase any of those or more than one of those, then you're going to make your electromagnet stronger. Why does a compass react when placed near an electric circuit? We did try this out in class. Remember that a compass is really just a little magnet. It picks up the magnetic field of Earth. That's why we use them for direction. But what's happening is the compass is picking up the magnetic field that's produced by the current. So this is B. Current produces a magnetic field. Compasses don't produce. They are a tiny magnet, so they have a magnetic field. They don't produce any kind of electric field. But current has both, and the magnet's picking up the magnetic field part of that. For the picture shown, when will the voltmeter show the greatest value? Again, this is electromagnetic induction, like we just talked about. So when the magnet is moved quickly through the coil is when we're going to get our greatest voltage value. Okay, that means we're inducing a current through this coil here. We've got to move it quickly. We have to keep it moving. So not moving it won't work. Outside of the coil won't work. Move slowly won't work. We want a changing magnetic field. And then the last question here talks about motors and generators. So we talked about these as an application of electromagnetism. And remember that motors, okay, use electrical input to create a mechanical output. So a motor would be like a fan. Picture you plug your fan in, that's your electrical input, and then the blades spin, so you get a mechanical output. And then generators are kind of like the opposite of that. They use a mechanical input, like some kind of movement, to create an electrical output. A generator might be a windmill. Okay, it uses the mechanical motion of the arms turning from the wind power to create electricity. Or a power plant where you've got the big turbines that turn and they create electrical energy. So that is, it looks like that's D here. Okay, so just remember those two, motor and generator, what goes in and what goes out for each of those. So, okay, that was just a quick electromagnetism overview.